Hello everyone, today I'm going to explain and talk about friction. So what is friction? Friction is a force that resists the movement of two contacting surfaces that slides relative to one another. Okay, friction can be divided into two kinds of friction, which are static friction force, Fs, and the second one is kinetic friction force, Fk. Fs is used when the object has no motion or impending, while Fk is used when the object has motion or moving. The formula for static friction force is given by Fs equals to mu s n, where mu s over here is representing the coefficient of static friction, and n over here is the normal force acting on an object. On the other hand, kinetic friction force is given a formula of Fk equals to mu kn. Mu k over here is representing the coefficient of kinetic friction, and the n over here is representing the normal force acting on an object. Okay, let's just see the graph over here. The x-axis is P, which is the applied force, and the y-axis is F, which represents the frictional force. Okay, as P increases, the static friction force, which is F, increases as well here. Okay, until it reaches a maximum value over here, Fm. And for further increase in P, it causes the block to begin to move, and F drops to a smaller kinetic frictional force here. Okay, as you can see, there are 4 blocks over here. Okay, for the first 3 images, it shows that the blocks do not slide down over here for these 3 first images. Okay, for the first case, you can see that the angle is equals to 0, which means that there's no friction force acting on the object. And for the second one, the angle over here is smaller than the angle of static. This shows that there's no motion acting on the block, and the block does not slide down over here. And for the third case, the angle over here is equals to the angle of static, which means that the angle of response, this angle, is equals to the angle of static. So it shows that the motion is impending over here. For this case, the object is still same with the previous one. The object is still on the surface and does not slide down. Okay. And for the fourth case over here, the angle of response is already exceeds the angle of static, so the block will slide down over here. Okay, this is because the W sine theta is already more than the kinetic friction force, so the block will start to slide down over the fourth case over here, so there is a motion acting on the block. Okay, now let us see an example that shows friction is present. Okay, after this experiment, we can compare the effect of frictional force using these 2 examples. The one on the left hand side, I put an object on an exercise book, which is a smoother surface, and another one I put the object on a rougher surface, which is a chopping board. After this experiment, we can compare the differences between them when I tilt both of the surfaces. Okay, so as you can see, that the object on the smoother surface slides down first, the one of the rougher surface slides down after the smoother surface. Okay, when the object starts to slide down, the angle between the surface, which means the exercise book, and the table, okay, which means the angle over here, is smaller compared to the rougher surface. Okay, the angle over here is larger, the angle over here is smaller. This means that the frictional force between the contacting surface of the exercise book and the object are smaller compared to the rougher surface, which is the chopping board. Okay, so we can conclude that the rougher the surface, the bigger the angle is needed for the object to slide down. Thank you.